Today we're going to continue looking at completing operations with imaginary numbers. So yesterday we practiced adding and subtracting. Today we're going to look at just multiplying complex numbers. So today's date, please put that in the top corner of your notebook. And then the title of today's notes will be Multiplying Complex Numbers. So the first thing we have to review is just remember the complex number always has I in it. And that I, which is equal to the square root of -1. So this is the letter I, we kind of write it in a fancy notation, equals the square root of -1. And doing this allows us to solve problems that have quadratics where you solve them and you get an imaginary number with the square root of -1. Or if you have answers that have negative square roots. All right, so something special happens when you have the value I squared. So let's say I wanted to square this. I'm going to square both sides. When you square both sides, you come up with a special property where the value of I squared winds up equaling to -1 because the square root and the square cancel. So this is important to know because when we get to multiplying with complex numbers and you have I squared, you can replace that value of I squared with -1. So let's look at some examples that we can practice together. So let's say I gave you this one where I was asking you to distribute 3 times the quantity 2 plus I. So this one, you guys should remember, we know how to do this. This is just distributing. So I'm just taking the number on the outside and multiplying it by the values on the inside of the parentheses. So 3 times 2 is 6. 3 times I is 3I. So this is just distributing. So when you're multiplying with complex numbers, you follow the same properties of multiplying with the distributive property. What's different is if you have, let's say I had I as I was distributing an I. So I'll have 2 plus 2I. So we're going to take I and then times the quantity 2 plus 2I. So I'm distributing I, so I'm multiplying both things by I. I times 2 is 2I. But I times 2I, that gives me 2I squared. And so remember what I said about I squared above. Whenever you see I squared, it really turns into -1. So I can rewrite this as 2I plus 2 times -1. Notice I put it in parentheses because we're not subtracting, we're multiplying there. So really this simplifies to be 2I minus 2. And the way we really should write that is in the proper notation, the real number, then the imaginary number. So this one has a little bit more steps to it, but it's still pretty easy because all you're doing is multiplying. And as long as you know the properties with I and multiplying I times I, giving you I squared, you can turn this into this version. Let's take a look at one more example with the i's and multiplying, and then I'm going to give you another type of problem that we're going to see as well. Let's say I distributed -I. We'll do a -2 minus 4I. So the same first step as we did before, you just distribute. So I times -2 is positive 2I. And -I times -4I is positive 4I squared. Because a negative times a negative is a positive. But remember, we just talked about whenever you see I squared, that turns into -1. So I can rewrite this then as 2i minus 4, which is finally negative 4 plus 2i. One more example we'll look at, and then I'll show you the other types of problems that you'll see as we're working in this unit. Let's say I had 2i times 3 plus 4i. So 2i times 3 is 6i. 2i times 4i, that gives me 8i squared. Then remember, anytime you see that I squared, you rewrite it as negative 1. So I have 6i minus 8, or negative 8 plus 6i. Remember, you always want to write it in the standard form of real plus complex. So the only really new thing we're seeing here is with I times I, you get I squared, and I squared can be rewritten as negative 1. The other types of problems we'll see are where we have to do double distribution. So one of those problems that we'll see are when you have two sets of real numbers. Let's say I have 5 plus 2i times the quantity 3 plus 4i. So double distribution just means I take the values in this one and I multiply the 5 by both of these and the 2i by both of these as well. So you have to distribute twice essentially. So I'm doing 5 times 3, which is 15. And then 5 times 4i, which is 20i. 2i times 3 is 6i. 2i times 4i is 8i squared. So again, I just took the values in this one and I multiplied by both of these, and this one by both of these. But here there's an extra step. I have to combine like terms, and I also have to deal with this negative 1 because I have an I squared here. So I have 15 plus 26i, because 20i and 6i makes 26i, plus 8 times negative 1. Eight times negative 1 is negative 8. And now I can combine and get 7 plus 26i. So when we're doing multiplication with two sets of complex numbers, we're taking 5 plus 2i, and we have to multiply the 5 by the 3, and the 5 by the 4i, the 2i by the 3, and the 2i by the 4i. From there, we simplify. One last example. We'll put some negatives in here this time. Negative 2 plus 3i, 4 minus 4i. So same thing, we're going to double distribute. So we're going to take this number and multiply it by both of these. So negative 2 times 4 is negative 8. Negative 2 times negative 4i is positive 8i. Three I times 4 is 12i. And 3i times negative 4i is negative 12i squared. Combine like terms and simplify. So I have negative 8 plus 20i minus 12 times negative 1, because I squared, anytime you see I squared, we turn into negative 1. So it's negative 8 plus 20i plus 12. So negative 8 plus 12 is 4 plus 20i. So that's multiplying with complex numbers. You just got to make sure you pay attention to that I times I, which gives you I squared, which also equals negative 1.